Here we have some integrals to calculate. Let's start with the first one that we can see here, integral of the cosine of 7x dx. This integral is quite easy to calculate. We can just simply write down the solution because it's very easy. Sine of 7x divided by 7. So if you take the derivative of this expression here, you will get exactly the cosine of 7x. And at first it might not be so intuitive to do it straightforwardly, but another way to find out that the solution is this one without even having to guess the solution is the following one. So you can rewrite the integral like this: integral of the cosine of 7x, and then you put the differential of 7x, and of course you have to divide by 7 here, the entire integral. Then in this case we have 7x here and 7x here, so it's like the integral of the cosine of x dx is the same thing, and the integral of the cosine is the sine of the argument 7x. So this is the solution. Let's not waste too much time on this because this is the easiest one. And then we have the integral of x times e to the x squared dx. In this case, you can see here that we have almost like a derivative of the argument of this. So instead of x here, I want 2x because the derivative of x squared is 2x. So I have 1/2 integral 2x e to the x squared dx. And of course, the integral of 2x e to the x squared is just the integral of the exponential. So because you can also rewrite it like this: in 1/2 integral of ex squared dx squared, like this, right? And the integral of the exponential is just the exponential itself. So this is just equal to e to the x squared divided by 2. This is another very simple integral. Now let's do another one. Let's do the third one. We have the integral of the third power of the logarithm of x plus 1 divided by x plus 1 dx. This is also an easy integral to carry out because we can rewrite it like this. We have the function logarithm of x plus 1 cubed on one side, and then we have to multiply this function by 1 divided by x plus 1. But if we integrate that function, we have integral of log to the third power x plus 1, the differential of the logarithm of x plus 1 here, because the integral of 1 over x plus 1 dx is just the logarithm. Well, in principle, you have to also consider the absolute value of this, so it's x plus 1 here. And why not put it? So if you want to be very rigorous, we have to put the absolute value here, but that's not really important in this case, because in order for the logarithm to exist, we know that x should be greater than or equal to minus 1, right? For this logarithm here, so we are assuming that we don't need to put the absolute value here because we know that if, for example, x is less than minus 1, then this logarithm here would not exist. So that's why I don't need to put the absolute value in there. And this is another simple integral to carry out because it's like the integral of x cubed dx, because the variable in this case is this one, the logarithm of x plus 1. So the integral gives me log to the fourth power x plus 1 divided by 4. And let's do another one before concluding and continuing in the next video. Let's do number 4. So integral of the square root of the cotangent of x divided by sine squared x dx. Well, if you recall from derivatives, the derivative with respect to x of the cotangent is exactly minus 1 over sine squared x. Let's prove it quickly because this is very easy to do. The derivative with respect to x of the cotangent of x is the derivative with respect to x of the cosine of x divided by the sine of x. And this is minus sine x times sine x minus cosine x times cosine x for the usual rules of the derivative of a ratio of functions divided by sine squared x. And here we have minus sine squared minus cosine squared, so this is minus 1 over sine squared x. So we can rewrite this as minus integral square root of cotangent x differential of cotangent x. And this integral is like the integral of square root of x dx, right? And it is quite a simple integral to carry out because this is x to the 3 halves divided by 3 halves. So it's 2 over 3 x to the third power and also the square root, so it's x to the 3 halves. And therefore this is minus 2/3 cotangent of x to the third power and also, well, let's say to the 3 halves. That's easy to say. So this is the solution of the last integral that we did in this lecture. It is the fourth one, and then from the next lecture we are going to do some more complicated integrals starting from here, from number 5.